Hi, my name is Jason Vasquez. I'm here with Mike Uckman. Today we're talking about the exciting topic of REST versus JsonAPI versus GraphQL. Just by way of introduction, I'm one of the co-founders here at DeveloperTown, and I've been involved in developing web applications, mobile applications, and everything in between for more years than I like to admit.
I'm Mike Uckman. I'm the API and Integrations Practice Manager here at DeveloperTown. My experience is in many different technologies and lately has primarily focused around .NET and the .NET stack.
Why bother talking about this whole thing? For us, we get this question quite a bit when we're starting new applications, either from clients, how should we structure something, or we'll hear about this, like, oh, there's this new GraphQL thing. What should we do with that? Is that something that we should go after? Here at DeveloperTown, we've built a number of applications, many applications across all of these stacks, and just thought it'd be worthwhile kind of walking through today some things that we've learned along the way, some things that differentiate them, and how you might go about making that decision in your application.
What are these things? I don't think you can have a meaningful conversation around these newer technologies without talking about SOAP first. SOAP is a protocol. It's maintained by the W3C. It was designed by Microsoft in 1998, and it's really why REST exists. REST is an architecture style. It was founded by Roy Fielding in his PhD dissertation in 2000 as a response to some of the rigidness of SOAP as a communication protocol. JsonAPI and GraphQL, those are specifications. JsonAPI was drafted by Yehuda Katz in 2013, and V1 spec was released in 2015. And GraphQL was developed internally at Facebook in 2012 and released publicly in 2015. So the major difference between that here is that REST is, like I said, an architecture style, which means it's open to many different interpretations. Whereas JsonAPI and GraphQL, those are rigid specifications that dictate what the implementations should look like. All of these things are really just ways of defining communications to and from web services, and you have many different implementations to choose from. Things like Apollo, or there is a JsonAPI.NET Core implementation. Choose your own adventure as far as that goes.
To me, the big differentiating factor here is, if you remember back to the SOAP days, SOAP was really an RPC protocol. You defined functions on your server like get me the list of users, that kind of thing, and it would return a nicely structured list of things. There's a lot of negative reaction to both that style of interaction, and then just the fact that it was largely based in XML and some pretty complicated things around XML schema, even though tooling support actually was pretty good in those days. REST, as kind of a reaction to that, really moved more towards a document-centric model. So you think about stable URIs like amazon.com/book/123. That's not a real URI, although you can try it. But you can always expect to get that book from that resource and treat it like a resource all the time. So when you look at the verbs, and we'll get into those in REST and JsonAPI, these are more things like create a new resource or get a resource. To me, those are kind of the big differentiating things to think about as we compare these.
So let's talk about REST and what it means to be RESTful. REST stands for Representational State Transfer, and it's built as a response, like we said, to the SOAP protocol and its rigidness. It's built on top of HTTP, so everything that we're used to, all the get, post, delete, put, patch, etc., for most of your CRUD operations. It's built on 6 core principles. We have the uniform interface. This is a way for resources to have a single logical URI, and it provides a means to fetch other relevant data. It really means that if I consume an API endpoint, I should understand how to consume other API endpoints from the same API. So really just uniformity in what the exposure surface looks like. We can bring up something here, the HATE OAS, or Hypermedia as the engine of application state.
Otherwise known as the worst acronym ever.
This dictates that you should be returning links to possible follow-up requests in your responses. So if I ask for a book, I should also potentially receive a link to how to get its author or other related resources for that particular object. Client server, this is really just everything that we're used to doing now and doesn't require a whole lot of work. It really says that the client and the server should have no dependencies on each other. I should be able to work on the UI without bringing in outside resources for the API and vice versa. And the client should really only need to know the relevant URIs that it needs to access the server. Stateless, well, this is just the nature of HTTP. We don't store any state on the server, and everything we need to process a request should be handled within the request itself. So things like auth, bearer tokens are a pretty great example of this. The client sends back everything that we need to potentially authenticate a user for every request. Caching should be applied when applicable, and resources should define themselves as cacheable. And really, this is where we see a lot of performance gain from RESTful services because of the nature of HTTP and caching. A layered system, this really just says that the client shouldn't know whether it's connected to one server or another server, anything intermediate along the way. This is what allows us to do things like load balancing and spreading out different services across different servers. Code on demand is an optional principle. Really, it just says that the APIs should be allowed to return executable code to the client. So where this becomes useful is, let's say the API has some special widget that always needs to be available. It can potentially return to you executable JavaScript or any other code that might be required. Let's talk about the pros of REST. It's most commonly built on HTTP. So that's good. Means we have things like error handling baked in. Things like a 200 says all good, a 403 says go authenticate, and a 404 says these are not the droids you are looking for. Discoverability, predictability, scalability. If you're using tools like Swagger or OpenAPI, then your services become neatly discoverable. REST itself doesn't really provide a lot of discoverability out of the box. Multiple data formats. JSON is preferred, but Jason mentioned previously that SOAP is built on XML, and you can do XML with your web services through REST if you want, if you're the type of person that really enjoys that kind of pain. JSON is more performant because it takes less resources to parse. Since the definition of REST is very flexible, you have your own flexibility there to build it in a way that makes sense to you using the technologies that you're already familiar with. So let's move on to the REST cons. It's most commonly built on HTTP, so that provides no subscriptions. Loose interpretations lead to poor implementations. Since this is really just built upon one guy's PhD dissertation, you can have all kinds of crazy stuff come out of these implementations. Overfetching data, this is the core problem of REST and why things like JsonAPI and GraphQL really have been on the rise. Let's say you have these calls here to get items and their descriptions. The first problem is if I want to get multiple items, I have to make multiple calls to the API. And then if I want to get their descriptions, I have to make yet another call. So perhaps you think, well, I'll just make an endpoint that returns fully hydrated items with their descriptions and their users that are attached to them and all this data. And that looks great for your particular one web application. And then your mobile app comes along and it really only needs, let's say, 5 properties out of this item object, but you're sending it 50. Well, you're overfetching the data, and that's not very performant because you have to actually serialize and send all this data every time, even though you're not going to use it. So that's a major drawback to this type of RESTful approach.
I think for me, when I look at REST and why I might or might not use this, I think if you want to create your bespoke interface to your application, this is the way to do it. There's not a ton of deep opinion as to how you might structure your URIs or what specifically that data might look like coming back, so you can really shape that to how you need. And that's great on one hand. On the other hand, if you go that route, that really requires really great communication between your API developers and your front-end developers, if those are different individuals. There's things like, do you get back part? If you're showing a list of books or something, do you get back part of the book for the list view and then like a detailed version of it for the detail view, what are those different types and what might a client developer expect to get out of those? How does that change over time and how do you communicate that? Those are the kinds of challenges we've seen. They're certainly workable, using tools like Swagger or OpenAPI really ease that quite a bit. But it's certainly something to be aware of as you take on projects like that.
JsonAPI, or as I like to call this, REST++. The picture here has this person herding all the kittens, so I felt that was appropriate.
Hurting the kittens or hurting the kittens?
Herding.
It doesn't look like they're getting hurt.
They're getting loved on.
Loved on, okay.
What is JsonAPI and what is it trying to accomplish? It really just extends typical RESTful behavior with well-defined structure and data relationship capabilities. So it's opinionated in the way that it accepts requests and gives responses. It's designed to minimize the number of requests to a web service and amount of data returned. What it really gives you is a way to ask for data that you need and nothing else. In that sense, we can ask for something like a book and its author, or just a book, or a book with just its title. We're really able to efficiently minimize the number of requests that we need to send to a web server based on our needs at the time. And an excerpt here from the JsonAPI spec page, their goals of the media type are to balance a generic media type that can work across a broad set of use cases, including the generally used relationship types, similarity to existing server-side framework practices, ease of implementation on the server side, and ease of implementation on the client side. So really that to me just says their main goal is to make something that's easy to build using the practices that we're already familiar with. And I think it does that pretty well. If we take a look at some sample code here, a JSON API request and a REST request and their responses, we can immediately see there's some differences between the way these things are handled. I wanted to point out here, we can use JSON API without anything else as just a strictly RESTful implementation. The difference here is that we're going to have much more opinion on the way that that response comes back. The first element you'll see is a data element, and that's actually, we can do that on REST as well. That's part of Google's JSON formatting guidelines for responses. We see that built into JsonAPI. The big one that we need to worry about here is the attributes and the relationships. The attributes are really just what we would call the properties on the object or the fields. The relationships here is the special piece. That tells us that this particular article has an author with an ID of 42. And this becomes important later on when we see more of these requests. This is where the magic really takes off. We can here see we're asking for an article, we're including the author, and we're using something known as a sparse field set. So we're specifying the fields for an article, we just want the title and the body, and the author. And the fields for people, which an author is a person, we just want their name. So coming back here, we see that we're getting the same kind of data, the same kind of relationship, and we're getting an include where we're bringing the author of type people, and his name is John. You can kind of mimic this behavior on the RESTful side if, again, you start fully hydrating your objects, but then you run into the problem of, well, what if I don't want the author? So this is, again, that balance where we can start to query something with JsonAPI that we can't achieve the same type of query level with REST. So let's talk about the pros of JsonAPI. We have more control in the hands of the client. So again, as you see with the queries, we can ask for things in meaningful ways. The relationships are separate from the attributes, and this plays into also the last point here, deduplication. We can ask for specific things out of an object and still get back its relationships. Those relationships map to how objects are included. And because of the relationships tag, we don't bring back several copies of the included objects. So we know that for our particular request, we have an author and maybe we have several articles with the same author. We don't need to bring in that same author for each article. We just add it to the end and add relationships so that our client code can actually make those joined relationships come alive without duping all the data. We have things like built-in pagination and built-in error objects, built-in filtering and sorting. A lot of functionality comes out of the box and is required by the JSON API spec, so we don't have to reinvent the wheel and build these same things that we build over and over again. So let's move on to the cons of JSON API. One thing that I had experience with personally was the documentation for the implementations is actually rather poor. And I'm particularly aware of this with the JSON API .NET Core implementation where there isn't a whole lot to go off of. So if you have some issue that's maybe non-standard, it's a little bit difficult to figure out exactly how to handle that. And because these things are fairly new, Googling for fixes to these problems can often result in very few hits. Most implementations of this operate over HTTP, so we get no subscriptions again, and implementations generally promote DB models directly to the client, which it's not a good idea to promote your database schema to the outside world.
For me, this has been kind of an interesting transition in this conversation. If we really call SOAP the starting point, we had kind of a rigid RPC setup, strong reaction to that in REST, right, where we went to kind of a resource-oriented, loose way of defining what you need to get done. to JsonAPI, which is, to me, kind of sitting in the middle. It's still this resource-oriented nature, allowing you to be fairly flexible, but providing some structure around it so you can know what to expect, right, when you encounter one of these things. Mike's comments about the implementation, I think the current implementations out there today, I think are spot on. I know those will improve over time, so I don't call that a huge knock today. Those are going to get better and better as we go, and I don't think JsonAPI is going anywhere. I feel pretty comfortable with that as a future-looking option for applications. But to me, what he mentioned at the end there was the biggest hit. I actually looked to go migrate an application to JsonAPI that I was working on, and it's possible to not do it this way, but some of the default implementations out there today really, to make things easy, for instance, in the .NET environment, you can just expose entities that you already have as JsonAPI endpoints. And that's really powerful. That's cool because you're done in minutes, right? And it works. But the more I look at it, the more that the way those entities are structured, that's kind of an implementation detail of how they're stored. And that's not really something I necessarily want to expose as the public-facing domain of my application, which the business domain might be different because there's just different needs there. So again, just more trade-offs to think about there is what's important to you and how that can play out. On to GraphQL. I'm here to talk about this one a little bit just because we've done several of these applications now with GraphQL, and I've learned some of the ins and outs and what's worked well and what hasn't. It seems to be a bit of a mystery as to what to do with it, so I thought we could talk through this. GraphQL is a little bit of a different beast than REST and JsonAPI in this conversation. It really centers around this query language. It was originally created by Facebook back in the late 2012 era. It really kind of hit public release in 2015, so relatively young, just like JsonAPI. One of the big goals that they had in this is allowing front-end developers to write their own queries. And it's not strictly database queries. We're not saying that they can write select statements or that kind of thing, but using this language that GraphQL defines, it allows a front-end developer to ask for what they need or what they want at that point in their application, and allow API developers to expose those in a way that makes sense. It's transport independent according to the specification. You're going to see HTTP pretty much everywhere. I don't think I've actually seen anyone else do it, but like all specifications, they like to cover all the bases. Like, sure, you could do this over SMTP, in email, great. I doubt anybody's actually going to do that, but you'll see HTTP quite a bit. So I thought we'd jump into what does this actually look like. And following a little bit on the prior examples from JsonAPI, this is what something might look like typically with GraphQL, where you commonly see gets and different HTTP verbs in REST type applications or JsonAPI applications. For the most part, clients tend to use POST with GraphQL. Now, it's totally possible to do it with GET. In fact, we'll maybe have some examples later that show this, but this is a common way of doing things. You can see on the right with REST, maybe we're trying to get kind of this like short format of an article. I just want a couple of fields out of it. I don't want everything. I don't want the authors and related links and all of that kind of stuff. So in this case, a client developer would have to have a conversation with an API developer and say, hey, I need to be able to tell you that I want these article details, but I just want like what we're going to call this short format. On the left with the GraphQL side, what you see is the client developer can just ask for what they need. Now there's probably more to it, right? There's probably author and body and subjects and all kinds of things. But in this case, they're asking for articles with ID and title. And so you can see the response there in the end looks fairly similar, with the distinction being that in the result set, articles is a element within the JSON response. The reason for that is that you can also issue multiple queries in one request. So I may be asking for articles, and then I may also be asking separate to that for some profile information on myself, for instance. So I might ask for articles, and then as a sibling to that node in the query, I might ask for profile info. And I could get, then in that case, you get multiple responses back, articles and profile, which would be siblings in the response. Here's an example of getting the details on a particular article. So on the right might be something you've seen before, get /article/1. That means give me the article with ID 1. We kind of presume that you want to get all the details, so we give you back the full list as we know it of fields and properties that make up that article object. On the left, similar to what we saw before, just blown out with a lot more details. So in this case, it's kind of interesting. This time we're asking for all the articles, but you see there's a parameter there with ID of 1. So it's a filter. Now this is application defined. This is not necessarily a structure that's built into how to get a collection of things with an ID. think of it like an RPC call, honestly, that there's a function on the server that queries articles, and it takes a parameter that just happens in this case to be ID. And so what we're saying in this query is for every article that comes back, give me these fields. Give me ID, title, body, created, updated at, and author. Now author's a complex type, or it's an object in and of its own right. So for each author, give me ID, name, age, and gender. You can see in the result, what we have here is this case of articles that return an array of one element and returned the fields that we asked for. Very similar response if you look at both. The only difference is that, especially I think as you look at this author one, this is where it starts to get interesting. In the REST request, we had to communicate with the API developers and say, yes, always give me all the detail on this author. On the GraphQL side, I was able to ask for specifically these things about an author. And that we start to get into people and social graphs and that kind of thing. And remember, this came from Facebook. This all fits really well into that space. So maybe author has a related links type property to it, or maybe other articles by this author. That would be something that would be really straightforward to query with GraphQL in this way. Let's talk a little bit about what's great about GraphQL. Subscriptions. We mentioned this earlier. What we mean by this is this ability to use a WebSocket type interaction and get real-time updates for when things change on the server. Classic examples of this are things like chat applications or any kind of application with multiple users where you want to see live updates. Think about things like Google Docs. If you're editing Google Sheets with someone else, you can see those updates live. That's kind of a neat thing. It's baked into the specification. The way it works is very much like the queries. You provide a subscription query, and basically anytime something matches that subscription, you get back an object callback with the parameters that you requested. We put it here as a pro, and you actually may see it either way, that they have separate types for mutations. This is interesting in the sense that you may have some things like, think about a user object, and we go through a registration process. When you create a new user, it does not have an ID yet. It's only after it's been created, right? So you have an input type, basically they call it. So you may have a user input type that you define that has everything but the ID, and then when it's created, it comes back as a user type, and it has the ID and created at maybe and some other things like that you define. As we said before, not opinionated about the network layer, which is usually HTTP, or the payload, usually JSON. And that's actually what gives it a little bit of flexibility around subscriptions, because you see the same kind of messaging that happens over WebSockets and some different things like that. This is, to me, a real key differentiator is API documentation is automatic. Per the specification, an API needs to be self-describing. There's a couple of different options out there, but really the thing that everybody uses is a tool called Graphical. It's a play on GraphQL. Imagine, look at the top of the screen where it says GraphQL, put an I after the H, it's graphical. And it's a UI tool basically to navigate your API, look at the documentation for all of the different types and functions that you can call on there. You can include markdown formatting in those, and so it's a pretty straightforward, easy way to communicate to your API clients as to what they can do with it. One of the things that we found to be interesting is it allows the API development team to be distinct from the front-end development team. API development team can expose everything they want to expose about a set of data, and the clients can then use it as they need it over time. And sure, there's going to be communication back and forth over time, but it does decouple that a little more strongly in terms of team organization. Lastly, this leverages some of the tooling on the client libraries that you use. Specifically, I'm thinking about the Apollo client right now for GraphQL. It's one of the most popular clients out there. You may request that, as we looked and saw before, that article object, which was kind of a thin record that we got the first time around, then later we went back and got more detail. These clients maintain some state in themselves, and they work really well with reactive frameworks like, say, React or Angular or Vue or others like that, so that you may initially fetch that first object. As you go back and fetch it again, that store continues to update, and then your UI can respond. So as things change, you can expect your user interface to be consistent throughout the application without worrying about stale data somewhere that might have changed over time. On the cons, the biggest one that we found was that it comes with a high learning curve. When you look at REST versus JsonAPI, they're all pretty straightforward. JSON's really easy to understand. I'm a little biased given my name, but it's pretty easy to see URLs and how they map to documents and that sort of thing. When you come to GraphQL, it really is, you kind of throw all of that away. Now we're starting where primarily you have one endpoint, it's this /GraphQL or wherever you mount it, it's up to you. And then you're going to learn a query language that goes with it and a whole host of supporting technologies. Error handling is robust, it's well defined, but you do have to think about it a little bit differently. If you go back to that concept of you can issue multiple queries at one time, that kind of goes along with the fact that you may get one of those queries works perfectly well, but the other one doesn't and fails in some way. So error handling in GraphQL is unique in that you're typically going to get an HTTP 200 OK back from the server. Everything's fine, but inside the response, you'll see that you have some data and then also an error element populated. This is handled pretty well by the client libraries, but if you're just going to try and go it alone and write stuff on the wire directly, it's going to be a headache. Development support tooling is around, but it's young, like everything else in the space right now. I mentioned Apollo earlier. They have browser extensions and some different client tools that are really useful and helpful. I've personally experienced some instability in those, and they generally work, but it's a frustrating moment when Think seems to hang up and you just got to kind of close the dev tools and open them up again. One of the nice things, again, I'm kind of picking on the Apollo team, but they're launching a for-pay service that is an API monitoring service. And if you've used New Relic or tools like that, it'll help you look at your queries and see which nodes are slow or which things are taking more time so you can optimize those. There is a really high risk of N+1 queries. What we mean by that is I asked for a list of articles, that's query 1. And then I went through and I needed to get the author for every article. So then I'm going through and asking for author 1, author 2, author 3, author 4 as I go down. This can be really slow, obviously, create a lot of load on your database servers, a lot of memory usage on your app servers. One of the things that's insidious about this is that when you test it locally, a lot of times you don't notice. Extremely low latency from your local app server to your local database, pretty much near zero, and your data set's probably small locally. When you head out to the server and all of a sudden you've got a optimally 4 millisecond round trip to your database and a million records out there, all of a sudden you just brought the whole thing to a crawl, and that's going to be a bad day. So there's tools out there to help. Tools like Data Loader are quite good. They help you collect up elements that you need to go query and then batch get those, and they're arguably competitive performance-wise with joins and that sort of thing. In some cases, much better actually. So just kind of depends on your use case, but definitely worth testing. The last one that's I think a big kicker to me is that there's no opinion on API versioning. It's kind of up to you what you want to do with it. Now, if you've got your API hosted at /GraphQL, there's nothing to say you couldn't come along and put a second one at /GraphQL2, or something like that, and replicate the whole thing, but with whatever modifications you had. The word from Facebook on this, or at least from some of the engineers from talks I've seen, are more along the lines of just don't make incompatible changes, only make additive changes and deprecate properties over time, which may or may not be satisfying. Again, your mileage may vary, so just something to consider as well. Really, to sum it all up for me, if I look at should I use GraphQL, should I not, I definitely would put it in the not category if my main goal was to publish a public API. If I were Twitter and a large part of my business is around consumers of my public API, GraphQL is probably not my go-to choice. Given some of the cons we saw here, that it's kind of a high bar for people to implement on the client side, I'd rather go with something more simple. If I have a development team that's well organized, kind of a well-oiled machine, I think it's actually a great option because it allows, again, those client developers to get what they need when they need it. But if I've got a junior team or somebody that's still coming to terms with web technologies and how to operate these things, again, probably not my go-to choice. So beyond the technology, there may be even some more considerations in terms of your team's ability to pick up new things and run with them.
If you're interested in reading about some of these specifications, the links are posted here. The last one at the bottom is Google's JSON style guide, which is something that's good to mix into either new or existing RESTful services, just to bake in a little bit of opinion into how those responses should come back.
Thank you for checking out our Developer Town MindMeld series. For more information or questions, you can reach us at info@developertown.com.